Today I will show a short video about our topic, which is the curl. What is the curl of a vector quantity, in this case a vector field? We can say that it is a measure of how much a vector field circulates around a given point. Well, a vector field doesn't exactly circulate, but here we have an example vector field. You can see that the orientation of the vector field appears to be a circle around the origin. If we take the origin right here, you can see that the arrows indicate the flow. We can see that the arrows are flowing around the origin. Notice it would be flowing slower when we get close to the origin, and will be flowing faster as we go farther away from the origin. So, the magnitude of the vector field increases with increasing distance or increasing range away from the origin. So in that way, what we call the curl would be a measure of how much circulation there is. The differential operator is equal to the partial derivative with respect to x, which is the component I, plus partial derivative with respect to y, which is the j component, plus the partial derivative with respect to z, which is the k component. The general way in which we work that out is the vector field f can be written as the cross product of the differential operator and the vector field itself. By using the matrix format of I, j, and k on the first row, on the second row we would have the partial derivative with respect to x, y, and z on the second row, and lastly the x, y, and z component of the vector field. Now we take the first element times the partial with respect to y times the z component minus the partial with respect to z times the y component. Now, by taking the second element, we alternate the signs, plus minus plus. Negative j times the partial with respect to x times the z component minus the partial with respect to z times the x component. Now lastly, we take the third component, which is the k, times the partial with respect to x times the y component minus the partial with respect to z times the x component. And now that is how we calculate the curl. Notice that the result of a curl is a vector itself, a vector which is a magnitude and direction. The direction of the curl will be perpendicular to the plane of vector field. The curl will be up or down depending upon the direction of the circulation of the vector field. By using the right-hand rule, the curl will be positive when the circulation is counterclockwise, just like in this example. The curl will be negative otherwise. Therefore, we can say that the magnitude of curl indicates how much the vector field changes when moving one unit in the x direction and one unit in the y direction.